Hello, this is Steve Markstrom. I work with the U.S. Geological Survey in Lakewood, Colorado. This is part of the PRMS training video series. I'm going to give a quick overview of the Precipitation Runoff Modeling System, or PRMS. This is our latest version. Here's a schematic showing how PRMS views the hydrologic cycle. Basically, these components are simulated on every HRU, hydrologic response unit, in a watershed. Basically, up here are the inputs to the model: air temperature, precipitation, solar radiation if you have it. Things are computed down through the plant canopy. Here's the soil surface, the root zone, soil zone down through the depth of the roots. Then deeper than that is the fully saturated zone. These arrows right here represent the components of flow that are summed together that contribute to stream flow. This diagram comes directly from our user's manual, which brings up a good point: documentation. We get a lot of questions about PRMS documentation. The first thing we offer is the PRMS user's manual. This is pretty new. It came out this year. You can go to this URL right here, get it, or you can go to the USGS Publication Warehouse. Just type that into Google and you can search for my name or PRMS, whatever. You'll get this techniques and methods document. The second resource is the PRMS webpage. There's a lot of stuff here, including the current executable and the source code, previous versions of PRMS going back, I don't know, several years. You can get all that stuff here. There's the URL for that. That's where you're going to have to go to get the model. The third resource we offer are the training videos, of which this one that you're viewing is part of. You can get these from our website and just click through them. Basically, these are patterned off the training course, our standard PRMS training course, week long. The lectures that we present during this week-long training course. Reports and articles also. If you go to our website, there's a page there that has basically everything that's been published about PRMS that we know of. There could be more. This is a pretty good resource. A lot of USGS report series and journal publications as well. There's the URL for that. Finally, as we release new versions of PRMS, we update a few of the tables. In Appendix 1, there's a table that lists the modules, a table that lists dimensions, a table for parameters, and a table for the variables. If there are any changes, basically, and these would correspond to changes to input and output of the model, if there are changes for the current version, you can click on this link right here and get these revised tables. Here's an example of an updated version of Table 1-5. It's been updated for PRMS version 4.0.1. Basically, anything that's different from the published table and the user's manual is highlighted. You can see we've added a few variables. If you look at these things, there are just summary variables that don't really change anything that the models do. The user needs to know that they're there. If you are running PRMS, you should download these tables for a version that you just downloaded. Those are on the PRMS page as well. Basically, PRMS uses the continuity equation at its heart. The change in storage is equal to the input minus the output minus errors. You can see some of the terms in this equation that we're looking at. Very general overview of how PRMS works. PRMS does have a relatively standard set of units or dimensional analysis of the units. Basically, any kind of storage in the model is expressed as depth per unit area. What that means is that the volume is expressed in terms of length. Likewise, flux is expressed in terms of depth per unit area per time step. Since the time step is always 1 day, that tends to go away. That part of it's just dividing by 1 here. Basically, our storage and our flux are in units that we can go back and forth with. PRMS scale. We have successfully applied PRMS on watersheds of tens to tens of thousands of square kilometers. With our HRUs, can be much less than a square kilometer. If you watch this video series all the way through, you'll see some scales that are much larger than tens of thousands of square kilometers. Temporal scale, 1s to hundreds of years, are pretty typical on a daily time step. Discretization of space. To set PRMS up, you need to have essentially maps of definitely these first three and optionally subbasins. If you're going to use subbasins in your model, PRMS needs to know exactly what is in and what is out of your modeling application. Stream segments need to be defined, as well as space needs to be discretized into what we're calling hydrologic response units. Just a few of the terms that we use and have a very specific meaning for PRMS. Process and modules. Within PRMS, a process represents one of the major hydrologic processes or administrative tasks. PRMS has 17 processes. If you look at Table 2 in the user's manual, you can see the processes listed right here. We have many presentations in this series, PRMS training series, that go into these processes in much more detail. A module is a piece of source code used by PRMS to simulate a process. PRMS has 39 modules, and obviously because we have more modules than processes, the user has the option in some cases to choose which modules they want to use for simulation of a specific process. In this case, we're back to Table 2. In here on the left-hand column, you can see a list of modules listed. For here, precipitation distribution processes. You can see the 4 modules. Any one of those could be used to simulate that process. Dimensions. A dimension is a value. It is an integer value that is used to describe the number of values of a parameter or variable. Of getting to parameters and variables next. Every parameter and variable has at least one dimension. A dimension is comprised of a name and an integer value. Dimensions are read from the PRMS parameter file. I'll describe the parameter file later. Here's Table 1.1. It is listing the dimensions and a little description, the default values, and some notes about them. Anyway, here's where you can go to see the dimensions. PRMS also has a concept of parameters. Basically, a parameter is a static input value that does not change during the course of the simulation. Parameters are declared by the active modules. Basically, the modules that are being used for the simulation of the different processes. Parameters are declared as arrays. Even if there's only one value for that parameter, then it's an array size of 1. Values from the parameters are read from the input parameter file. It could be real or integers. Here's Table 1-3. This table is a pretty big table. Lists all the parameters that are in the current version of PRMS. You can see the parameter names, some descriptions, which dimension is associated with the parameter, the type, the units, valid ranges of the parameters, the default value, and some notes over here about how to use the parameter. PRMS also has a concept of variables. A variable is a value that can change each time during the simulation. Likewise, they are declared by the active modules in PRMS as well. Must be declared as arrays, just like the parameters. The input variables, not all variables are input, but the input variables are read from the data file and are real or integers. Table 1-5 lists all of the input and output variables. Another big table in the appendix of the PRMS User's Guide. You can see the variable names, descriptions again, dimensions, units, the types, and some notes about using that particular variable. That concludes this quick overview of PRMS. Thanks for watching.